Good morning. So we're now on derivatives. So in finding the derivative of a given function, so we are following the fundamental principle of calculus. That is actually the slope. So let's say if we have a given function of x, so its derivative is equivalent to f of x plus delta x minus f of x divided with delta x. So as we have derived so in the introduction for a given or the introduction in calculus. So if we are going to use this uh, method, okay, so this is what we are referring is the derivative by increment method. So this would be the long method so in finding the derivative of a given function. So before even using the different formula that we have, so in finding the derivative of a function, so we can use this general formula, okay? So to find the derivative of a given function. So let's say we have uh, y is equals to 7x minus 7, or let's say, or 7x minus 3. Okay, so that this is the given function. And then to find its derivative, well, that's just simply y prime. Uh, if you were going to use the power formula, so this would just be right away, it's equivalent to 7. But using the increment method, we're going to find its derivative. Okay, so this would be if we have y, so we could transform this one as f of x equals to 7x minus 3. So therefore the f prime of x then. So we're just going to change all x of the f of x to the following. So we have the x plus delta x. So 7x then, so will just be 7 times x plus delta x, then minus 3. So 7 plus delta x. So 7 times x plus delta x minus 3. So that is for the f of x plus delta x. And then minus the f of x. The f of x is the same. So which is 7x minus 3. And then everything is divided by delta x. Right away, this one should be, or the delta x, so should be approaching to 0. So the same is true with this one. So delta x is approaching to 0. So f prime of x then, so will be, so we're just going to perform the operations involved. So we'll have 7x distribute, and 7 times delta x, we have 7 delta x minus 3. So this will be the negative. So we'll have negative 7x, and we'll have plus 3. And then divide it with delta x. So you can see here, so we have 7x minus 7x is 0. Negative 3 plus 3 is 0. So leaving us to have the f prime of x to be the limit of 7 delta x over delta x. And then as delta x approaches to 0. And from here, so we can cancel out delta x. So it would just be simply the f prime of x then would be the limit of a constant, so which is 7 as delta x approaches to 0. So the limit of a constant is a constant. So therefore f prime of x is equal to 7. So let's have another example. The second one is 1 over x minus 1. So f of x is equals to 1 over x minus 1. So our f prime of x then, so would be the limit. We're using the same formula, so we're going to change the x to x plus delta x. So that will make it 1 all over, so x plus delta x minus 1. Then minus the f of x, so which is 1 all over x minus 1. And then everything is divided by delta x. And x or delta x approaches to 0. So from here, so our f prime of x then, so would be equal to the limit delta x approaches to 0. So we'll get the LCD. So the LCD will just be the product. Okay. So that is x plus delta x minus 1. Then multiplied it with x minus 1. So divide the product with x plus delta x minus x, so that would just be cancelled out. So leaving us to have x minus 1. So x minus 1 times 1. So we'll have x minus 1 here. Then minus. So x minus 1 would be cancelled out. So we just have x plus delta x minus 1. And everything is divided by delta x. So f prime of x then, so would be equal to the limit as delta x approaches to 0. So we could, this one is over 1. So we could have, or we could get the reciprocal of that as 1 all over delta x. And then multiply it with the numerator. Or just simply, so this one so would serve as the numerator. And then this one will serve as the denominator. So doing that, so I'll just have the delta x, the denominator, multiplied it with x plus delta x minus 1, x minus 1. And I'll have the numerator, so x minus 1, so negative x. Then I'll have a negative delta x, then a positive 1. So you can see here that x minus x is 0, negative 1 plus 1 is 0. So leaving us to have the f prime of x to be equal to negative delta x all over delta x, so x plus delta x minus 1, then x minus 1. So you can see here, so delta x would be cancelled out. So leaving us to have the f prime of x to be the limit as delta x approaches to 0. So negative 1 all over x plus delta x minus 1, then x minus 1. And then we evaluate the limit, so f prime of x, so we substitute 0. So that will just give us negative 1 all over, so x, delta x is 0. So that would just make it minus 1, and then x minus 1. So substitute delta x to be 0. And therefore, our f prime of x then will just be negative 1 all over, so x minus 1 squared. So that's a derivative using an increment method. So let's have another one. So let's say it's a derivative of the square root of x plus 4. So to find the derivative using an increment method, that will be f prime of x, so the limit as delta x approaches to 0. So we'll just have the square root of, So x plus delta x, then plus 4 minus the square root of x plus 4. And of course, divide it with delta x. So again, so just like the examples that we had, so for radicals, so in this case, so we can multiply the conjugate. Okay, so the conjugate, so we have x plus delta x plus 4 minus the square root of x plus 4 divided with delta x. So its conjugate would just be square root of x plus delta x plus 4. Then that is minus, so this make it plus square root of x plus 4. So divide it with square root of x plus delta x plus 4, and plus square root of x plus 4. And then since that is just the difference and sum, so we just square. Okay, so the square of the square root of x plus delta x plus 4, square it, minus square root of x plus 4, square it. And afterwards, so delta x, multiplied it with the square root of x plus delta x plus 4, then plus the square root of x plus 4. Then the f prime of x would just be the limit as delta x approaches to 0. So tanggal yung square root. So just have x plus delta x plus 4. And then tanggal din yung square root. Then distribute to negative. So negative x and then negative 4. Divide it with delta x, square root of x plus delta x plus 4, and plus square root of x plus 4. So from here, so x minus x is 0, so 4 minus 4 is 0. Then leaving us to have the f prime of x to be equivalent to the limit as delta x approaches to 0. So we'll have delta x all over delta x, and then x plus delta x plus 4, then plus square root of x plus 4. So this will cancel out delta x, and f prime of x is just the limit as delta x approaches to 0. This 1 all over the square root of x plus delta x plus 4, the square root of x plus 4. And then we evaluate the limit, so f prime of x then, so would just be, so change delta x to 0, so that will yield to 1 all over the square root of x plus 4, so delta x is 0, plus the square root of x plus 4. And thus, f prime of x, so would just be simply 1 all over 2 the square root of x plus 4. So that is f prime of x. Okay, so what if we have a trigo function? Let's say f of x is sine x. F of x is sine x. So our f prime of x then, so will be equivalent to sine of x plus delta x, then minus sine of x all over delta x. And then as x or delta x approaches to 0. So the f prime of x then, or before that, so we have to remember that if we have sine a plus b Okay, so we have an identity. So that is the sin cos sine A cosine B. So plus cosine A sine B. Sin cos cosine. Then our f prime of x then so would be the limit for the function as delta x approaches to 0. So we'll have x is a and then b is delta x. So that would be sine of x cosine delta x, then plus cosine x sine delta x minus sine x, and then divide it with delta x. And our f prime of x so will be equal to we can group, okay, so combine sine x is the first term and the last term. Then we could have the limit as delta x approaches to 0. I could factor out sine x, then matirasi cosine delta x, and then sine x divided with sine x, I'll have -1. Then I'll separate the plus cosine x sine delta x. And then everything is divided by delta x. So we can separate the two as two different functions. So that is sine x multiplied it with cosine delta x minus 1 all over delta x. The other one is plus cosine x and then sine delta x all over delta x. Then applying the properties of limits, so f prime of x, so since this is sum, so we can just distribute. So the limits of delta x approaches to 0. By the way, I could factor out the negative for the cosine, right? I'll just move it out, so to make it negative sine x, and then cosine would be negative, and then 1 would be positive. So to make it 1 minus cosine delta x. Then divide it by delta x. And afterwards, so plus the limits as delta x approaches to 0. And I'll have cosine x sine delta x all over delta x. So remember in the formula that we've used before, that is for the limits. So in here, it would appear that our variable here is the delta x. Okay. So since we have x here, so x is considered to be constant. So therefore, we can move it out. So this is the same as negative sine x, and then the limit as delta x approaches to 0, and we'll have 1 minus cosine of delta x all over delta x. And then plus the same as true, so cosine the limit as delta x approaches to 0. So we'll just have cosine x. Sine delta x all over delta x. So remember this one is equivalent to 0. This whole limit, this is equivalent to 0. Then this whole limit is equivalent to 1. And thus, the first term becomes 0. And then the second term is 1 times cosine x. So therefore, f prime of x is cosine of x. So which is true, di ba? So the derivative of sine is actually a cosine of x. Okay, so usually that's how we're doing the increment method. You may try on your own. So you'll have another activity for today. You'll be answering, okay? Or you'll be finding the derivative of the function using the increment method.